A shop has 7 different mountain bicycles. You came across information, write it down. 7 are mountain. 5 different racing bicycles. So 5 are racing and 8 different ordinary bicycles. On display. A cycling club selects 6 of these 20 bicycles to buy. They need to select 6 from these 20 bicycles. Okay. Now, what condition should it satisfy? How many different selections can be made if there must be no more than 3 mountain bicycles? In your selection of 6, there should not be no more than 3 mountain bicycles. How do you make sure that there are not more than 3 mountain bicycles in your selection? To represent that condition, here I write it should not be more means it has to be less than. So how many mountain bicycles ever you are selecting, that count has to be less than or equal to 3. Clear? Now. And no more than 2 of each of other types of bicycles. That means this also not more than 2. That means it can be less than or equal to 2. Even this also less than or equal to 2. This is the condition we need to satisfy. I have written that. Clear? Now question is, from these 20 you need to select 6 satisfying this condition. Did you understand? From the 20 you need to select 6 satisfying this condition. Since I get multiple options, I wrote in the table form. Okay, whenever you get multiple options, better to make the table. Now, with what number shall I start? It can be less than or equal to 3. So let us say if I start with 1. 1 means if I take 2 here, then here it has to be 3. The count is 6, but here the condition is failed because it has to be less than 2. So with 1 we are not going to get. Let us increase it to 2. If I take 2 of the mountain, then this also should be 2, this also should be 2, then only my total count will be 6. Condition satisfied. If I take 2 here, 3 and 1, the count is 6, accepted, but this condition is not satisfied. So this option you will not consider. Clear? So now let us increase this number to 3. If I increase it to 3, let us say I have taken 2 racing and 1 ordinary. Total count is 6 and each is satisfying the condition. Clear? Total count should be 6 with each satisfying the respective condition. Okay. Now, do I get any other option? Yes. How do I get? By swapping or interchanging these two. Let us say 1 here and 2 here. Again the total is 6, each satisfying the condition. Okay. See, writing in the table form is so much helpful to us. Okay. Now, do I get any other possible option? I cannot increase it to 4 because he said less than or equal to 3 only. So I realized only these 3 options satisfying the condition. Clear? Now let us write for each. First this one. See, from the 7 you need to select 2. That can be done in 7C2 ways. Now here, from the 5 you need to select 2. That can be done in 5C2 ways. From the 8 you need to select 2. That can be done in 8C2 ways. Since all this needs to happen at once, so it's into between them. So this is the answer for the first row. Clear? Now second row. From the 7 you need to select 3. That can be done in 7C3 ways. From the 5 you need to select 2. That can be done in 5C2 ways. From the 8 you need to select 1. That can be done in 8C1 ways. Since all the 3 needs to happen simultaneously, it's into between them. Okay. Now for the third row. Same thing. From the 7 you need to select 3. That can be done in 7C3 ways. From the 5 you need to select 1. That can be done in 5C1 ways. From the 8 you need to select 2. That can be done in 8C2 ways. It's and between them, so it's into. Clear? Now see. It is either this option or this option or this option. You have or between them. Whenever you come across or in statistics, you need to replace it by plus. So here this answer plus this answer plus this answer will be your final answer, and that you get it to be 13580. After adding all the 3, you should get this. This is your final answer. Okay.